Alrighty, intro to TypeScript. Hello everyone, my name's Emmett. I'm a fourth year software engineering student and I'm very passionate about TypeScript. And I'm about to tell you why and why you should use TypeScript in all of your web development projects. So first of all, what's TypeScript? Can anyone give me a quick answer, one sentence?
It's a superset of JavaScript.
Superset of JavaScript, anything else?
Types.
Types?
Yeah, JavaScript with types.
JavaScript with types, all phrases that are commonly flung around. So what is it and how does it actually work? So TypeScript is a programming language like any other programming language. You take it and you interpret it / compile it to another language and then you run it. So TypeScript is the language that compiles to plain old JavaScript that you would write yourself, and JavaScript that you compile out of JavaScript runs on a web browser just like any other web application. This is similar to the same way that if you take a C program and compile it to assembly, you can run it on your computer. So TypeScript, like any other programming language, just compiles to something that runs on a place. And someone said this before, superset of JavaScript. What does it actually mean when we say TypeScript is a superset of JavaScript? So I'd like you to imagine JavaScript. It's an object-oriented, web-based programming language with dynamic typing that's sort of functional. And by functional, I mean functional programming, not that it functions, sort of. And when people say superset, they mean that TypeScript is everything that JavaScript is, with a little bit more. It has static typing, it has a lot of really great backwards compatibility built into it, and because of the static typing and the language features, it has a lot of great tools and support around it. So technically JavaScript has some backwards compatibility with it as well, but TypeScript is a little bit better at doing it, in my opinion. And when we compile TypeScript, we shrink this outer bubble that contains all the TypeScript features into the smaller one that browsers can understand and run code, just like any other language, any other JavaScript application. So, why would we ever want to use TypeScript? I have a few reasons on the board, but can anyone else imagine a reason?
It's tired of writing JavaScript. You want something new.
Yes, you're tired of writing JavaScript. Has anyone ever been frustrated with writing JavaScript or encountered an error with JavaScript? Show of hands. A few people, yes. So JavaScript has a lot of very painful things that come with the languages that not a lot of people like. So a lot of those things are silly mistakes, and TypeScript comes with the static typing to enable erasing those silly mistakes. So for example, can anyone tell me why I get an error when I run this code?
You spelled it wrong.
Yes, I spelt it wrong. Why wasn't I told immediately that I spelt it wrong before it crashed?
Because you're not using TypeScript.
Exactly. More specifically, JavaScript is dynamically typed, and statically, JavaScript doesn't have the ability to pre-process the entire piece of code and check that everything is in the right place and has the right type. JavaScript was designed to be this way because when you're running a piece of code on a web browser, you don't have time to pre-process everything because that would cause your web app to be so slow. But now that we're in more of a modern computing society, we want to use all the tools at our disposal to make great web apps that are really secure. So if we run this piece of code in TypeScript, we actually get an error before we even compile the code. So here, TypeScript tells me I've got the error. Cannot find name, my employee profile. Did you mean my employer profile? It even knows to suggest the right keyword because of the great tooling it has underneath. And if we accidentally access the wrong field of the object, say last name instead of name, TypeScript can also tell me that that field doesn't exist on the object that I'm looking at. So before I've even run anything and crashed my web browser, TypeScript has already alerted me to the fact that I've made a mistake. So I'd like to tell you my personal story with front-end development. So I study software engineering, and as part of my degree, there's a lot of software engineering workshops which often involve building web apps that are written in JavaScript or any other language. So I've written my fair share of JavaScript, and I didn't like JavaScript initially. Countless amounts of errors, swearing and ranting in the group chat about how we should use a different language, smiling after I never had to write JavaScript again, a lot more swearing to do with JavaScript. over my last summer, I did an internship at a company, and before I went there, I said to myself, if I have to write one line of front-end code, I'm actually going to quit my job and come back home. The very first thing I was asked to do is write one line of front-end code. And rather than go back home, I just said to myself, yeah, okay, I'll just get on with this and give it a shot. And at this company, they didn't use JavaScript, they used TypeScript. After a while, I started to appreciate TypeScript. I started talking to my friends back home, telling them like, oh guys, like it's not so bad, like we can try use a different language next time, things will be better. I started preaching to people, like, guys, I'm excited to do this, I'm keen to do some front-end work in a good language. I even started converting people to TypeScriptism, people that like, along with me previously, had sworn to never look at that language again. Okay, yeah, I really ate my words there. So, enough talking about TypeScript. I'm going to show you what it's like. Let's get to coding. So, before we start, to use TypeScript, you have to have Node installed on your computer. So, for those that have never used Node, Node is an offline version of JavaScript that you can run just like any other programming language from your terminal. And Node comes with the package manager npm, which lets you install the TypeScript compiler. So, if I hop over to my terminal, if I want to install TypeScript, after I install Node, I just type in npm install TypeScript. Node does its thing and installs the package. Cool. And once I have that, the TypeScript compiler can be used via TSC. Yes, a lot of options there for us to work with. But we're not going to be focusing on any of that today. Just before I start, can people read this? Is this somewhat comfortable? Those of you at the back there, if you can't read what's on the screen, just put your hand up and I'll change it. So, I'm not doing this all from my head, just in case you guys think. I actually have a copy of the code that I wrote previously here, just so I don't forget about anything and miss half the workshop and wonder why I finished half an hour early. Okay, so in JavaScript, if we want to declare a variable, what would we use?
Let?
Yep, let. So I go let's say x equals 1. This is all well and good. And if I say x equals hello, immediately TypeScript has given me an error. Why? Because TypeScript has inferred that this x was a number. The string hello is a number, so I can't assign it to x. So implicitly, TypeScript did something like this. Now, for the rest of my document, whenever I reference y or change y, it must be a number. So, in TypeScript, you can also give types to functions, return types, and arguments. So let's say I create a function called f, and this takes 2 arguments, a number a and a number b, and it returns a list of numbers, or an array of numbers to be more precise. So this error that I'm getting here is TypeScript saying that I haven't returned anything that looks like an array of numbers. So this is really handy if you accidentally return an object that's not what your intended object is. And also, don't worry, this code is all on GitHub and it's already public, so if you want to get a copy of this after, it's all online. So don't worry about typing it up. So let's say I create a new array, or even I'll just return an array with a and b in it. Cool, and TypeScript is happy. This is an array of 2 numbers, so we're good to go. You can also declare the type of a function. So this function has a particular type assigned to it, and it's a random function that takes in 2 numbers called a and b and returns a list of numbers. If I wanted to create a variable to hold this function, I'd need to give it that type. So I'm going to create a variable called fun, and I'm going to give it the type, a function that takes in a number a and a number b, and returns an array of numbers. Cool. And if I wanted to assign this variable fun to something, I could set it to the function f that I've created. And that stores the function f inside this fun variable. If I wanted to test this, Now, to compile this, all I have to do is go to my terminal. I have this TS, and I'll do TSC for the TypeScript compiler on basics TS. Cool, compiles. The result I get out of this is basics.js here, which is regular JavaScript that you can run anywhere. So I'm going to run this with node. Oops, basics.js. Yep, and immediately it gives me the expected output, an array with 1 and 2 in it. Question?
Can I see how basic.js looks like?
It looks like you'd imagine. It's just regular JavaScript that loosely resembles what you did. Yes?
Oh. Can we write TypeScript and then compile to one left?
I'm not going to say anything because I don't want Andrew Taylor coming for me if I make a statement. You should ask him first and then come back to me. So this is somewhat a demonstration of what TypeScript does under the hood. I'll come back to you in just a sec. So TypeScript looked at our whole document. It realized the types of everything and checked that all the right types went into the right places. And then once it was done, it just deleted all the types. So when you actually run this JavaScript, it has no access to the type information that you put in your TypeScript document. It erases everything and runs it like normal. The guarantee you get from using TypeScript is that you put everything in the right place and TypeScript checked that you didn't make any mistakes. Question?
Does the error message come from the VS Code plugin or, the VS Code editor?
This one?
Yeah, some error message comes from the plugins or just the original?
So something like this?
Oh, yeah.
So the error message that you're actually seeing here. So VS Code is developed by Microsoft, and Microsoft also developed TypeScript. So naturally, VS Code has a lot of really great support for TypeScript. So TypeScript has a server called the language server, which runs in the background. And when you write TypeScript code in your IDE will tell the server, they just typed in this piece of code. Is it good? And the server will say yes or no. And it'll tell the IDE what line there's an error at and why. And the IDE just reports whatever the server says, saying, oh, you made a mistake. Here it is. Does that answer your question? Yeah. I think this is built in naturally to TypeScript. I have the TypeScript extension tslint on, which is really good, by the way.
Does that mean that whatever code that you're reading will be sent to Microsoft servers?
No. So to clarify, the server runs on your own computer. So VS Code will start that running in the background in your computer and just ask that program lots of times, what does this code mean? Is there any errors? Yeah. Yes?
You can get TypeScript support in Sublime Text as well.
Yes. A lot of IDEs have support for TypeScript because JavaScript is an easy language to reason about because it's so flexible. So naturally there are a lot of plugins for it all over the place. You don't have to use VS Code or anything to use TypeScript. I just very much prefer to use it. Okey-doke. Yes?
You have to download the compiler.
No, you just have to download Node Package Manager and do npm install TypeScript like we did there. Ooh, my terminal's a bit broken, just ignore that. I'll go over this later if you want, but let's move on for now. So, in addition to basic types, I might make that slightly bigger. TypeScript has what we call union types. So I'm going to make a variable called z, and this z has the type of number or string. A union type is a type that can be one of a series of possibilities. So this means if I have used this variable z, I can assign it to any number or any string, but only one. Or if there happen to be any numbers that are strings, both, but there's none in this case. So I can say z equals 2, that's 1, and TypeScript is happy, or I can say z equals hello, and TypeScript is happy. And if at runtime I want to check which one it is, here I could say if type of z is equal to string do something with z. Inside this if statement, TypeScript actually knows that z is a string here, because if it passed this check, it must be a string. There's no possibility for it to still be a number or a string. So you can treat z as a string and never have to worry about the case where it's a number inside this if statement. And you can do the same thing for number, but we get a very interesting error. And yes, I am aware that this is very dodgy syntax, using type of and using it equal to a string. So if I copy and paste this in here, we get the TypeScript tells us that Z is a never. In other words, this will never be true. You'll never get to this part of the code because TypeScript knows that the last thing we set Z to is a string, so it knows that we didn't change Z up to here, and we will never, ever reach this piece of code. Never is actually a very special type that we're going to get to later. Okie doke, what's next? Ah yes, and of course, if we set Z to anything else other than a number or a string, that's an error. Z should be a string or number, and TypeScript is telling us that an array of numbers is not good enough for string or number. So if I run that, and if I run the basics.js, yes, we get hello, because of course Z is a string. Alrighty. So in addition to union types and generic types like number, string, whatever, TypeScript has what we call value types as well. So if I wanted to set a type that only can be the number 0 or the number 1, I can do that like this. So I'll create a new type using the type keyword, and I'm going to call it bit, and it's going to be equal to 0 or 1. So TypeScript actually knows that if you created a number with type bit and tried to set it to any other number other than 0 or 1, you'd get an error. And if you use some function like z equals z plus 1, TypeScript would know, oh, you could get 2 there, so that's not good. So let's say if I want to declare a variable, let b, have we used b? No. Bit equal to 1, that's good. 0 is also good. 2 is no good. Yes, so TypeScript is already complaining that 2 is not assignable to the type bit because it can only be 0 or 1. Yes?
You have to use Visual Studio Code to look at the error.
No. Good question, actually. If I went to the compiler and ran that, I'd get the exact same error message out. Type assignable to bit, and it even happens. Okie doke. And I can create a new type called bitString, which is just a series of bits, by making it an array of bits. So once you construct your own types using the type keyword, you can continue to build more advanced types on top of that by referencing your own types in other types you create. Yes?
How do you know that it is consists of number 0 or 1 or string?
In TypeScript, those are two very, very different things. So for example, you could not do this in TypeScript. In JavaScript, if you have the string containing 1 and the number 1 in two different variables and you use double equals, that would be true, because JavaScript is designed to do that. But in TypeScript, it will actually warn you against using double equals, and it will ask you to use triple equals to strictly check the types. So the string 1 and the number 1 are very different things in TypeScript, and it can tell the difference. Does that answer your question? Yes?
Does it prevent overflow? Or like if I had 1 and then added 1 to it? Or
Let's see. Yes, it does. Number is not assignable to type bit. So what it's saying is that our type is specific to be assigned to a general number. First, we have to create a new bit, b plus 1, and that would involve that it is in fact 0 or 1. And then once we have a new bit, we can assign it to b. And that would involve checking each case. If it's 0, can I add 1 to it? Yes. Can I add 1 to it? No. And then it failed.
Would there be a way to put some mod to make it happen?
Good question. Mod. Is that how you do mod in JavaScript? I've never done it.
it is.
Yes, mod 2. No, not yet. We could write a function that takes in a number and returns a bit, and it will always perform that number mod 2. And that would be good enough for TypeScript to say, oh yeah, I'm happy with that, but we'll get to that later. So, in addition to numbers being value types, you can also have strings. So let's say I create a type family, and inside this type is the strings of all my family members' names. So Hannah, Evan, Mum, or Dad. I'm not going to put my mum and dad's name here. That would be weird. And I'm going to create another type called friends, which could be Hannah is my friend as well. My little brother Evan is not my friend. I'll put Nick and Danny in there. Okay. So what if I wanted to get all the value types that are both my family and also my friends? So some kind of intersection between these two types. Does anyone know what I would use if anyone's done TypeScript before? So it would be nice to say if family and friend. But that's not good in TypeScript. However, you can do this. What's it called? Oh, friends. And it immediately knows that FF has to be Hannah, and only Hannah, because the only common member between friends and is Hannah, not mom or dad or Danny. And this operator is what we call the intersection operator. And these are like using this sort of type that we create out of it is called an intersection type, where we take two types and we get what's common between them and allow only values that are common to both. So when you create something of this intersection type, TypeScript actually checks, is it one of those and is it one of those at the same time? And if it's yes, then you can assign it to that variable. So, for example, I can set FF to be Hannah, and TypeScript's perfectly happy with that. But if I tried to do something like Nick, that's not good, because Nick is a friend but not a member of family. Any questions?
So you can combine types.
Yes, you can combine types. Using or and is the most using what's called discriminated union, which is the bar thing we saw before, or this intersection here is the most common way of constructing new types, other than what we'll see later if we have time. Okay. And what else? Also interesting to note, if I create a new type called int and string and set it to all the numbers and all the strings, so TypeScript doesn't actually work out what all the possible values of number and string are, because there's an infinite amount, theoretically. However, I can tell you that there's nothing inside ints and strings. You could never create a variable that was both an int and a string, because if we try to assign it to a number, say 1, TypeScript is going to complain that 1 is not a string. And if we try to assign it to a string, TypeScript is going to complain that our string is not a number. And even if we tried to be clever and put it as a string that's a number, TypeScript is not happy with that as well, because they're two different things in the world of TypeScript. So you have to be careful when you construct types with intersection. What may seem like a compiler error to you could be a signal that you will never be able to construct this type because you made a mistake, and there's nothing that has both number and string, for example. Any questions?
So can we put a class or object or something in the tab constructor or something?
You could, yes. We'll get to classes and constructors in a bit. Okay, we're doing well for time, so I'm not worried.
If you have two members which are in both family and friends, then what would FF be?
Let's say I decided to write to my brother, which I do, and I wanted to add him to my friends as well. FF becomes Anna and Evan. So, TypeScript can actually work out all the absolute members of a family and a friend. Any other questions? Okay, cool. Who's familiar with undefined and null in JavaScript? Can you tell me what the difference is between them?
Undefined. I think undefined is when you're trying to access a field in an object that doesn't exist.
Yep.
Therefore, it's undefined. But null is more strict, I think, than undefined. Because sometimes you can. It's what you use when there's no value, right? But then
Yes.
undefined is also weird.
No, you're correct.
Okay.
So if I have an object with one field and I try to access a field that doesn't exist, I'll get undefined. But if I have an object that has one field that just has no value and I access it, I'll get null. So null is just like this exists, but there's nothing inside of it. And undefined is it doesn't exist. You're accessing nothing. So in TypeScript, these are actually their own types. And they're very special types because you need to keep track in your code of all the things that could possibly be undefined and null. Because using any undefined and null in a function or like trying to dereference them will crash your JavaScript program. And TypeScript gives you the ability to do that by assigning them strict types, undefined and null. Yes?
In other languages, like the int string, you set to null undefined? Yeah.
Let's try it. I have a feeling it's no. No, it can be. Oh, dangerous. Which is why it's really important that you always check for undefined and null in your code. Yeah. The sad thing about TypeScript is that because it's compatible with JavaScript, strings are allowed to be null or undefined and so are numbers. So this number and string object also contains undefined and null, which is annoying. Actually, I'm not sure if null is in there. It would just console.log null. But if I tried to add it to like the number 2, for example, then TypeScript would go try and do it, and then I'd get a runtime error, which is the problem, because it can't tell me before I run my program that there's a mistake. So I guess there are two things that can be in number and string. And to sum up everything we've done, I'm going to create a new type, C, and it's going to be all the things that evaluate to false in JavaScript. So undefined equals that, or null, or the empty string, or 0, or the empty array. Did I miss any? Or false, of course. So if you did if and any of these values, you'd get false, and the if statement wouldn't work. Any questions at all? Yes?
A type of number without undefined.
Can you make
excluding the
let x number? And you're asking me to check if there's a way. Yes, number you can, but is the one that you can't. No, actually. Oh, that's a different error. Yes, string is happy and number is happy. So you're asking whether I can do this where TypeScript forces me to say, there's no undefined in number. Off the top of my head, I believe there's a compiler flag that you can turn on that's like -- strict null checks, I think, which says anytime you try to assign undefined or null to a number or a string, TypeScript goes, no, not allowed, which is like a more strict version of the regular TypeScript. And that's built into the regular compiler, so you can always just do that. Creating a type that does that, I don't believe so. However, we can do this. And whenever I use this num, TypeScript is going to ask me, you have to check whether it's undefined or a number first before you use it, because I don't know which one it is. Which forces you as the programmer to make sure that it's not undefined before you use it, which is more useful. Okay, so let's do something a little bit more advanced. I will just save this. Okie doke. And I will switch over to my other tab. Perfect. Okay, so in JavaScript, sometimes you just don't know what type your variable has. Can anyone give me an example or think of a time when they can't give a type to a variable? Yep.
If I'm making my own custom container,
No, you could make your own custom container and give that a type, right? But if you called some function, say, and got something back, and you weren't sure what was inside the thing that you got back, you can use this type. Pardon?
JSON.parse maybe?
Yeah, JSON.parse will return a random JSON object, but you don't know what type of object it is. So in JavaScript, we have this type called any. And this type is basically, I have no idea what this is. You can do whatever you want to it. And if JavaScript had types, every object in JavaScript would have the any type. All the numbers and strings are just any by default. So what this type means is that you can do anything you want with this type, even if it's not valid. So what do we immediately think about the any type?
It's just JavaScript.
Yes, it's just JavaScript. And you want to avoid using this type whenever possible. There's even a compiler flag that tells you no implicit any, or like you have to like explicitly say it's any, and you also have to do something else to like say, yes, I absolutely want to use any. So for example, if I console.log my input, JavaScript is happy with that, TypeScript, and if I do .name, TypeScript is happy with that too. It doesn't matter what my input is, whether or not it has this name. This could very well be an error, but TypeScript goes, yeah, I don't know anything, so just do whatever you want. So, why would we want this type though? Why would we want to use this at all? Yes? No? There wasn't a hand up?
Because we have no idea.
Compatibility of JavaScript?
Yes? No idea and compatibility. Two excellent reasons, and I think those are the only reasons. So if you're using old JavaScript code, you don't want to rewrite in TypeScript, you can just include it and TypeScript will ignore it and then call the functions when necessary. But if you don't know what type you're getting back from those JavaScript functions, you can just say, okay, they have any, and I'll come back and assign them a type later. Because you already know they work. You've been writing that piece of JavaScript code for 10 years maybe, and you know that what comes out of there is what you expect. And also, let's say if you make an API call, and you get an object back or a string back from some server overseas. You don't know what types that server has, and it's not going to send you the types with it. At least most of them don't. I hope you're not sending types with your objects. So you can just assign it to any, and then think about what it might be, and then figure out what the type is at runtime, and then assign it to a more specific type. So if I were to create a new type called name, and this is just going to be an object that has the name field, which is a string. And I'm going to make a new object that is a name, equals. And according to TypeScript, I have to give this the name field. So I'm going to give it a name, and it's going to be, why not, Emmett for me. And if I chuck this into our log function, TypeScript is happy. Perfectly happy with that. And if I did log input.name, TypeScript is also happy with that. The problem is that TypeScript is also happy with that, even if I do this. No error, even though we can see plain as day that that's going to crash. So let's try run this. Yes. That comes out of doing input.name. Because when we do one.name. Undefined does not exist on one. So, error. And if we tried something like .join or .split to see all the characters inside the name, and recompile, yes, we get an error, and it crashes. So TypeScript at runtime goes, okay, input.name undefined, and then it tries to do .split and goes, oh, I can't do that on undefined. That has to be a string for that to work. Because we used any, TypeScript doesn't know that that was a mistake. Yes, so we'll just go with input. Doesn't crash. So to deal with this, there are certain situations where you want to strictly say to yourself, oh, I actually don't know anything about this thing here, and I don't want to trust it or pretend it has some field until I absolutely check that it does. So they invented this type called unknown. Very mysterious type. And I can assign it to this object that we created above, the one with the name field. And if I try to do console.log u.name, even though it exists, TypeScript is going to give me an error saying property name does not exist on type unknown. Because I declared u was of type unknown, TypeScript throws away all the guarantees I know about whatever object I just assigned to u and pretends it doesn't know anything. So in order to use this type, I actually have to prove to TypeScript that it does have something inside of it, and this is what it is, and then I'm allowed to use it. So going back to our example of you make an API call to a server overseas and you get back some data, you don't know what the data looks like or what shape or what kind of object it is. So let's say you treat it as unknown by default until you can confirm that it has all the fields it needs to have, then you can cast it to the type that you need it to be. So to do this in TypeScript, we create what is called a type assertion. So I'm going to create a function, hasName, which takes in some argument that is unknown and returns the assertion that arg is a name type. What's it complaining about? Unknown spelling. I guess name. Ah yes, and now I have to return a value. So what this arg is name means is that I have to give a true or false statement whether or not this argument that I passed in has the type name. So what would I do to do this? First of all, I want to check that it's not undefined or null. Does everyone know what that means when I do not arg? So what not arg means, if it's undefined or null, not will turn it into false, because negating like a falsy value will return it into a false value, and then doing not again will turn it into true. We'll come back to that another time. And I want to check that the type of my argument is an object, and the name field exists in this object. Everyone happy? Right, so once we've done this, this is like a mini proof to TypeScript saying that like, this is the object that we intended to be, and I can confirm that arg is name. The sad part about this is that TypeScript doesn't know that whatever you wrote in here proves this exactly. So you could say arg is string and string is empty, and then say arg is name, and TypeScript will be like, yeah, that's good. I like that. So unfortunately, if you make a mistake in your hasName function, then you've made a mistake and you've put something into the name type that's not allowed. The cool thing about this though is that you've centralized your unit of error to one function. So if you accidentally convert something to the name type that shouldn't be, and you get an error at runtime, you know exactly where that error must have come from. One place. So if I try to use u, I can't, right? As we saw earlier, u.name doesn't exist. But if I go if hasName u, inside here, TypeScript knows that u is of type name, because after calling the function hasName, we return this assertion that arg is a name. So TypeScript goes, you proved to me that arg is a name, or your u is a name, so I know that it has the field name that's a string. So it's more than happy to go console.log u.name inside here. And inside this if statement, it knows that u is of type name, of course. Any questions? Cool. Okay. Now we move on to my favorite type. Yes, you can have favorites in TypeScript. So earlier, we tried to assign something that was number or string and check that it was a number, and we got type never. Does everyone remember that? So never is actually another special type. And what it means is that a piece of code will never be run, or a portion of code will never be reached, if you will. So I'm getting this error here because I have a function that will, when it runs, it'll get to the end immediately and finish. And TypeScript tells me a function that returns never cannot have a reachable endpoint. So how can I ensure that I'll never reach the end of this function? Infinite loop is good, but I don't think TypeScript is smart enough to say, actually, maybe if it's basic enough. Yes, okay, it's happy. Infinite loop, that's good. Anything else?
Exception.
Exception is a good one. If I throw this message, TypeScript doesn't treat that as ending the function. It treats you as destroying the program and then going backwards. So you never reach the end of the function. So why on earth would this be useful? So let's say you had a function that was running your whole application and you want that function just to keep looping forever. You want to ensure that somehow you never actually exit that function, because that means your application crashes. You can assign your function to type never, have a while true in there, and then TypeScript will ensure that you never get out of that while true accidentally by doing a break or something.
Where do you call itself recursively?
Ooh, I like that. Let's see. Nah, TypeScript isn't that smart, sadly. Although you're definitely correct. Okay, so let me make this type some values. And it's going to be equal to 1, or 2, or 3, or 0. Actually, I'll make that even more confusing. A, for some strange reason. And I'm going to create a function. Functions, whoop. This function takes in whatever variable called that is of type some vals, and it returns a boolean. Okay, so I haven't returned a boolean, so clearly we've got to do something. So I want to check the case, or do something depending on which value I encounter. So I'll do, like, say, a switch on x, and if I have case 1, oops, case 1, then I'll do return true, as it's 1, and I'll do maybe the same thing for 2 and 3. Cool, I'm happy. What's the problem?
You have to returning undefined again.
Yes, returning undefined, which is not a boolean. And what's even worse about that? Undefined has a false value, so if you used it in an if statement, it feels like this function has returned false, even though that's not what actually happened. When does that case happen, by the way?
All with A.
Yes, when A happens. So it'll go through 1, 2, 3 and go, oh yeah, none of those exits. That's a problem. And I want to ensure that that doesn't happen. I want to ensure that all the cases are checked. So I will use this will definitely fail function that I created earlier. And I'll say will return will definitely fail of x. No, that's not good enough? Oh, sad. Yes. So what I'll do instead is I'll change this to never. And now I get an error. Argument of type A is not assignable to parameter never. So TypeScript knows that this message cannot be constructed because you can never make something with the never type. And if I got to this piece of my code, will definitely fail. And I passed in x. That means somehow I created a never type, which is not allowed. And so TypeScript will look at all the possible cases for x and say, this A, somehow you can get to this piece of code when x is A, and you're trying to use that as the never type. So that's definitely not allowed. What's the benefit of this? Anyone?
Ship to the bug.
Pardon?
Ship to the bugs.
Exactly. We caught a bug. I missed out on this A case in my switch statement. which would have ended up with the function returning undefined because I didn't return anything. And TypeScript has immediately detected that I missed a case. So now I can fix this by going case, lowercase a, return false. And TypeScript knows that I'll never get to this point, so it goes, cool, I'm happy, that compiles. And what's cool, if I change this compiles type later, let's say I want to add a b, TypeScript will go, oh, you need to fix this code down here. You've added a new value and your switch statement doesn't capture it. Not good enough. So I can do this. Oop. Default. Type 1 is never assignable to never. No, I have no idea what it's talking about there. But yes, adding the b case. There is also a compiler flag, I don't remember which one, called, I think it's strict null checks, but it forces you to check each possible case inside the switch statement, so you can't forget one. But I like this because it uses the never type, and that's my favorite. Any questions? Okay, this is where we get into the really wacky types in TypeScript. So, I'm going to create a type called isFunction, which takes in what we call a type parameter, t. Who's written Java code before? Anyone? Yeah. This is kind of like a generic in Java. Treat it as the same thing, if you will. And I'm going to set this to t extends function. T otherwise never. So, can anyone take a guess at what this line does? What this type isFunction does? Take a wild guess.
Did you check whether t is a function?
Yes?
T is a function, you can use it.
Yes, you're very close. What's the otherwise case?
If it's not a function, then just tap on it will never.
Yes, exactly. So I've created this type isFunction, and it's expecting me to put in a type in place for this t. And what it does is it checks that this type t is a function, and if so, then it gives it the type t. Otherwise, it will assign the type never to it. And we immediately know that that's a compiler error, because you can't assign the type never to something. So let's create some variable, let fun equals. So this syntax, does everyone know what this is? Put your hands up if you're comfortable with this syntax. Most of you? Okay. For those that aren't, this is a function that takes in nothing, and it returns the number 1 all the time. So the type of this function is nothing to 1. Yes? Or something. And if I were to say let definitely def_fun for definitely a function, and I'm going to assign it to the type isFunction and give it the type of fun, and then I'll set that equal to fun. TypeScript is happy with this, and what's the resulting type we get back? Nothing to number. So what TypeScript is when it used this type, you filled in type of fun, which is this we created here. And TypeScript goes, okay, t in here, I'm going to replace it with this type, the function that takes something and returns a number. So this check, is that type that we put in a type of function? And it goes, yep, that's definitely a function. It takes in nothing and returns a number, but still a type of function. And so it returns this type t instead. If I did this instead, we get an error. The type unit to number is not assignable to the type never, because the type of number is not a function. So that whole check fails and returns never instead, and then we can't use this. We get a compiler error. So we have a type level assertion that whatever variable we assign to this and the type that we put in there is definitely a function. So TypeScript comes with a lot more of that. In fact, I believe in the standard library of TypeScript, so you can use it out of the box. But I just wanted to see show you what constructing it is like. So I'm going to create a new type called num_return_type, and it's going to be equal to the return type of my function fun. So my function fun is a function that takes in nothing and returns a number, and this return type is a special type that takes in a function and returns the return type of that function. So it takes in this and goes, this is a function, I'm happy with it, and it looks at the return type of that function, which is number, and says, okay, the whole thing is equal to number then. And it assigns it to num_return_type. Questions?
Sorry, so what can this kind of thing be used for?
Good question. So let's say some really dank programming. And what I mean by that is you're taking in functions inside a function, and they're functions you got back from an API call or something crazy. So
Sorry, is that higher order function?
yes, a higher order function. Correct. And you want to use this function. But in order to type that, you want to ensure on the type level that whatever you put inside that function is definitely a function. So you could use this isFunction type. And let's say you're taking in a generic function, and you want to return in the return type of that function. In fact, I'll type that one up. Something like function executes. It takes in something which is a function, and it returns the return type of function, which it won't like. Yes. We'll give it the more generic type of function. Yes. So this return type expands to any, and this execute function returns any. I wanted to ensure that this function type that I pass in is more specific than any, then I can change this type, and I don't have to change the return type of this function, because it will just return the type of whatever this function is. And so I can just say return fun, and that's correct, because it returns whatever the return type of this is. And that's more correct than just saying any. In fact, it's so specific, it returns whatever this type is. And now for something really strange. I will change this back to whatever it was. I'm going to create a new type called type of fields, which takes in a t. And if t extends some kind of object, then what we want to do is we want to look at every key in this object. So for every k, which is a field of our object t, we want to infer what the type of that field is. So for every field inside the object, figure out what its type is, and then return that type. Oh, that's not the right one. Return that type, or never. Never might be too specific. Any questions about this before we move on? Okie doke. So I'm going to create an object, and I'm just going to assign it some random fields. So I'll give it x, which is 1, 2, 3, y, which is hello, z, which is actually more complex than that. Z is an object, and it has something inside it, which is an array of strings, and a, which is some empty array. So, what are the types of all the keys of this object? Let's go through one by one. What's the type of X? Number? Y? String? Z?
Object.
You can do better than that.
Object.
Yes. Object containing a field ZP, which is a string array, is the type of that. Specifically with the field ZP. And A? Can we do better than empty array? Not quite. This close. Array of any. Because anything could be in this array. We don't know what this array is filled with because we haven't put anything in there yet. So it could be an array of anything. Let's see if TypeScript agrees. I have to assign that to something like X. Yes, and it tells me that the resulting types of this is string and object that can be array of strings. Automatically, we've created a type that could be any of the fields of X, or any of the types of fields of X. So if I wanted to work with any random field from that object, and I want to know all the possible types that that field could be, I can create a type which extracts all those possibilities. And then when I'm working with this object, I just check every case and deal with each one separately. Any questions?
If you had that flag that said not to use any, then using empty arrays would hit that flag, then I presume.
Not to use any.
Yeah, this is separate to specifically this.
That's more like you can't declare your own variable any. But if you encounter something that's you don't know anything about, then that's allowed to be any. So it'll force you to do the best you can, and any is definitely not the best you can.
Yeah.
Any questions? Okay, so it is 12:02, and this room is booked from now on, as much as I'd like to go on. And there are still two files that I wanted to go through. However, 12:30. Everyone happy to stay till 12:30? Okay, cool. So, last thing I want to show you before we get into the more advanced stuff. Okay. Bye. Okay, so for those of you leaving, just leave quietly, please. So, let's say I want to use this TypeScript that I've created and use it in a web page. So far we've just been running things in the terminal, but what if you actually wanted to use this inside an application? What you would do is take any file. So let's make a new file called, or even better than that. Hello? And I'm going to call it run.js. And I'm going to compile this with the TypeScript compiler. And so out I get from this is this run.js file, which is just regular JavaScript that I can run. And it happens to be identical to the TypeScript that I put in there. So I've also got this file in, which is going to be my web page. Where is it? I'll open it up, and I'm going to include that run as a script tag. For me. I'll open up this run.js. VS Code knows that it's there. So when I actually serve this web page, it's going to grab the run.js like every other JavaScript and use it. And if I go to the web page serving index.html, hello. Yes, so my JavaScript, we took some TypeScript, we compiled it into JavaScript, we attached it to this web page, and we were able to correctly serve it and run it. Cool. Right. The last thing I wanted to teach about before getting more into it is interfaces. I don't want to start that now because that will maybe take at least another 20 minutes and then we'll be hushing out by the people that are coming after us. What an interface basically is an struct in type. It's a way of constructing an object type that has all the fields that I can create an object message, which is indicated by this question mark. Be a number, a string for the sender, a string for the receiver, a function in this object which is in the message and returns a false after it's sent. And I can use this by creating a function that matches the type of send and then construct a message object in the interface I created earlier, some field, and putting it into this. There's a bunch of other things I can do with this interface, but interfaces are the most common way to assign types to objects. If you've got some common object, say something you're getting back from an API call, and you know what type it has, you would define an interface for what type you expect that object to be, and when you get it from the API call, you return some type assertion that like, oh, the thing I just got back from this call is an object and it's a message, say.
So in TypeScript, is interface a tag like in Java? Or?
It's a type, but interface in Java is more like an expectation for what you have to be there. Like it says, oh, you've got to have this, 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 and this. And it's loosely related to classes. It's pretty much the same thing in TypeScript. But you can be a little bit more flexible with interfaces in TypeScript. One of the other things you can do in TypeScript is extend interfaces. So if you create a class and you say, I want it to have everything that the message has, then you could say class something extends message. You can't do that with type that we've been using. Type something equals whatever. And lastly, but not least, yes, classes are really good in TypeScript because in JavaScript, classes are just regular objects and they're very hard to work with because the types will get thrown away. However, in TypeScript, because we can rely on the fact that classes have types, they're very useful. So I can create a message, some parameter t, a string or a number, and I've got and a function, just like message interface had. If I wanted to say this message to interface message, then I can do that if I want. And called onSend, which returns a and it just runs the send function that you construct this object with. And then info will just message being sent by the sender to the receiver. So I can send function just and then I can message and then do all the other stuff I want. What's cool about classes is that you can use instance of. So if I create an unknown type and I say, oh, if this unknown type is the instance of a class I made, then I can treat it as that class and do whatever with it in here. So if you want to go play around with this code, which I encourage you to do, this is all on GitHub. And I'll post the link to this in the event as well, so you can look at it afterwards. And yes, feel free to change it, use it, do whatever you want with it. There's no license, so you could sue me over it if you wanted to. Any questions before we go on? Cool. Thank you guys very much. Thanks for coming. Yes?
Could you recommend any framework or something to work with?
Ooh. Okay, I'm very biased because I really like React. React and TypeScript is a dream to work with. We are doing a React workshop next week. I wasn't planning on making it like TypeScript focused, but I might have a little snippet of how you can combine it with TypeScript in there. But React works really well with TypeScript. And I know that Angular 2 onwards uses TypeScript for their default. So either of those two work well with TypeScript. But React.